Hey, don't go anywhere. There is no problem with your mic, neither with YouTube, neither with the internet, neither with me. So I just used a sign language, uh, which you might not know very well because we hardly use sign languages, but sometimes we use sign languages. So today's topic is regarding the reinforcement learning. So now why I have taken this example of sign language? Because actions speak louder than words, right? So as it is rightly said in the literature, reinforcement learning makes use of such an example in order to implement. But when we talk about reinforcement learning and compare it with the other machine learning techniques or the deep learning techniques, there is not much implementation, or still the research is going on into this field. So we'll have a brief introduction of what the reinforcement learning is in this video. So let's begin. So I'll give the simple definition of reinforcement learning. So reinforcement learning is the art of optimal decision making process. So this definition is quite simple because you'll give a set of actions, and based upon that you will be given to take some particular action or some particular decision. So in fact some system would be there like this, and you will perform some action, and the system will also perform some action, and you will be there, that is actor, and then it will return you some set of actions or some set of instructions. So that's basically how this works, and based upon all these given actions what you have, you'll take the appropriate decision. So that is the basic driving force behind what the reinforcement learning is. Now there are some building blocks with reinforcement learning. So the first is the environment. So in the environment, that is in the real world, that is say I'm making this video, so this particular is the environment. So in the environment I have state. So state is I'm currently making this video, interacting with you in front of the camera, so that is the state. Then comes the action. So I'm speaking, I'm discussing, I'm communicating, I'm trying to teach you something, so that becomes the action. And then the reward. So reward is your comments, your subscription, your good feedback that you give me, your suggestions that I take as the feedback or the reward. Then is the agent. So agent is me, that is an actor. So agent will perform action. So based upon the action in this particular environment, so an environment is one big container, inside that you have state. So state keeps on changing every now and then, at every time period state changes, and then action also changes according with the state. So with each and every action the state gets triggered accordingly, and you will get the reward. So when agent performs some action on this particular system, this will give you some another set of reward or a state change, or this can also give you some action back. Simple example to illustrate this thing which I currently spoke here is, say you have a coffee machine, and this is the user. So now this user or this actor want to have some coffee. So what he'll basically do is he'll insert some coin into this, say some these many cents, something like this. So initially before this coffee machine gives the coffee to the user, this will be in idle state. So this idle can correspond to this state. Now when the user performs the action, so first he'll insert the coin to this machine. So from idle state it will change to processing. So now given action, it will change from idle state to processing state, means it will do the internal activity of converting the milk to coffee or adding powder, adding sugar, those kind of activities, processing. And then processing, the user might have, during this period of time, he might have also given the action that he want a lid on top of the coffee. So the coffee glass or coffee mug looks like this, and he want to have some cap on top of this so that it becomes easier for drinking, so that it won't spill out by mistakenly. So he'll ask for this particular cap also. So that is another activity that is being performed inside this machine. So that will also get processed. So that is also one activity. So given this particular action, this machine will perform this. So then what it will output is, that is the reward that this machine gives to this user, that is the coffee plus the cap, that is this one. So this similar thing you can map with reinforcement learning. So these machines have developed because of these many use cases, that is reinforcement learning which it has. So internally, if there are some other errors that is happening, that is due to some kind of bottleneck that is caused due to this, or due to, if like the milk gets happens like it's empty or something kind of thing happens, so then this machine will go into an idle state, or then it will throw some error. So that is the basic ideology of what the reinforcement learning is, what the environment is, state, action, reward, and what the user gets in return for this. So this is the basic overview of or the building block of what the reinforcement learning is. Now reinforcement learning is divided into two processes. So first process is called as episodical process. So from the name itself, episodical means there are some sequence of episodes that is happening. If you have watched some web series or some serials, what happens is they have some episodes, episode 1, episode 2, then they'll stretch it for 1 year, 2 years. So that is basically what is an episode. So episodical process, it is given by this equation, that is, it is the reciprocal of the time period, and you have summation, that is t runs from 1 to capital T, and you have RT. So the RT is nothing but the reward which you get. So that is the episodical process. Then second thing you have called as the continuous process. So continuous process can be considered as an equation which is the addition of two things, but it's a polynomial equation. So it looks something like this. So R is given as R1 plus gamma R2 plus gamma square R cube up till gamma T, this is R, gamma T R T. So these are some equations that is followed. So if you want to generalize this, that becomes T runs from 1 to infinity gamma T RT. So these are two processes that is followed in reinforcement learning. Now in the beginning I've mentioned like it's a optimal decision making process. So from where the decision making process comes, or what are the roots of this decision making process in reinforcement learning? So these roots come from something called as Markov process. That is Markov discrete process, MDP. So from there it takes the decision making process. Now there is a much more probabilistic activity that is followed in Markov process. We are not going into that, but this is for the basic idea of from where the decision making process comes. Now in the beginning of this video I did some sign language, so you might have not understood what those things basically were. So in the beginning I said like hello, so that means hello. Then I said my, so then I did something like this, that is my name. Then I didn't tell my name because there are some other set of actions for telling that each particular name. Then I said I know something and I want to tell you something, and then I did like this. Again, if you didn't understand, I'll repeat it once again. I have to tell something. Then I did something like this, nice to meet you. So if you want to mimic those kind of activities in a reinforcement learning, it is easy, because say for example, if I am doing this activity that is sign language and you have an environment in that particular case. Say a person is there who is deaf and mute, so he cannot speak, but he can do, or these people basically communicate with each other or with other human beings who are not deaf mute with the help of sign language. So in the environment, so when we step outside, we can hear different noises of vehicles and everything. So it will be too noisy outside the room. So what happens if a person is communicating in sign language and if the other person is trying to understand? So what the deaf mute person is doing, they are imitating, or they are trying to explain with the help of actions. So that becomes easier. Now instead the normal scenario is like we tend to speak. So if there is too much noise outside and if we don't raise our voice and then we speak, then it becomes quite difficult to understand what the actual person is communicating. So that's why sometimes we say okay or something like this, I got it, things like that. We sometimes here and there make use of this sign language like this, something like this, no. So that's basically actions. So in order to model this reinforcement learning in the literature, there are few algorithms or a few techniques that is followed. So from this itself, that is the state, action, reward, you have a technique called as SARSA. So that stands for state, action, reward, state, action. So this is one technique. Then you have something called as DQN. So this is related with deep learning and neural networks, that is deep Q networks, deep Q learning networks, DQN. Then you have something called as A3C, that is action critic. So critic is someone who gives the suggestions. So if you watch any movies, there are people who like the movies and there are people who don't like the movies. So that's basically critics. So they give feedbacks or they give suggestions. Instead they don't give that, but they'll try to defame the movie in some other way. So that is critic. So this kind of learning happens here. And then the most common technique that is used, or one of the most widely used or majorly used popular algorithm in reinforcement learning is something called as Q learning. So we'll cover a separate video on what the Q learning is, and if we get some time then we'll discuss about DQN and SARSA techniques also. Now you might ask, what is the difference of reinforcement learning? Now reinforcement learning In the literature it comes under machine learning, but in machine learning also we have supervised learning and unsupervised learning. Then what is the difference of reinforcement learning with all those things like clustering, k-means, classification? We did many such algorithms. So in supervised learning or unsupervised learning, what we did was we gave some set of inputs, and then based upon the inputs, what we had is we had some predefined template. So that was the ground truth, and we expect the machine to produce in the similar way, and then we got some kind of accuracy based upon that, so that we tell our prediction. So in supervised learning and unsupervised learning, the target is fixed. Now in reinforcement learning, what happens is you don't give any input. So input as such you don't provide in a fixed way, because you are not deterministic about what the input would be. So if the input is not fixed, and therefore the target is also not fixed. So then you might ask how the machine learns in this particular scenario. So the machine learns with the help of the performance feedback that the user gives. So here you have some critic or some user feedback, and from that the particular machine learns in reinforcement learning. So that's why this technique is not that well established. Still the research is going on in this field. In the beginning also I did a sign language, so I'll take the same example here. So there, how did the deaf mute person understood like what he's trying to communicate? Like if the other person who is not deaf mute, if he is able to understand his language, that is basically reward. So that is the performance feedback that he gives. And similarly the agent here, that is the reinforcement learning agent, will learn from that and will try to communicate furthermore what he wants to convey. So there is a kind of give and take policy that is seen here. Instead of randomly or sequentially giving inputs or predefined inputs which you see in other machine learning algorithms. So this is a whole new different chapter, that is reinforcement learning. Still the research is going on in this field. So that's all regarding the reinforcement learning under machine learning, you can say. So well, that was all regarding in this video. Hope you guys enjoyed this video, and if you are new to this channel, please consider subscribing. Thank you very much for watching this video.